This video is sponsored by PCBWay. Hello there and welcome back to another video. In this video, I'm going to be refurbishing some old UPS units that I managed to get for free from my workplace, with the goal of reselling them for a decent little profit. These two beasts that barely fit on frame, even with the widest lens I own for my camera, are some old Smart Online UPS units from TrippLite. These are online UPS units, which confusingly doesn't actually indicate that they're manageable over the internet or LAN, but instead indicates the power handling topology of the UPS, and this differentiates them from the UPSs I've worked with before. This is because these units convert the AC input to a DC voltage, and when the power is good, the UPS uses this DC power to both charge the batteries and run the inverter for the outputs. This means that the unit is constantly regenerating the sine wave on its outputs instead of passing through the regular line voltage, making it exceptional for equipment that's sensitive to dirty power, as literally none of the original power will be making it through. It all gets reconverted. This is also really good because in the event of a mains power fault, the inverter is already active, and therefore there's absolutely zero changeover blip when the unit engages battery power, as it's all already working that way. So these are some pretty awesome pieces of kit, and the ones that I have are also big and powerful, with one being a 600 watt 750 volt ampere unit and the other doubling that with a 1200 watt and 15 volt ampere capacity. However, the issue with these units is that they don't work at all. You plug them into power and they act like it doesn't exist. You can press and hold the buttons on the front in all sorts of ways, and they never spin up their fans, click a relay, or provide power on the output. Thankfully, this doesn't seem like it should be too big of a deal, at least I think. Due to their functional topology that I just went over, if the batteries happen to be completely destroyed and dead, these units probably won't be able to even power up, as they need that battery power to kickstart the inverter and get up and running. So with that general background out of the way, let's start pulling apart the smaller unit to see what it's got inside, what shape the batteries are in, and how easy of a repair or how difficult of a repair it might be. Now, before I continue, I have to place an obligatory warning here. Opening mains voltage devices such as power supplies and UPS units can be extremely dangerous, and UPS units are arguably even more dangerous than the switch mode power supplies you hear about all of the time. This is because there can be full mains voltage inside of the unit sourced from the batteries, which can be way more capable of actually electrocuting you than just the capacitors in other units. Plus, in bigger units, the batteries themselves can easily be hundreds of volts on their own, and that's really quite dangerous to work around. You have to be really careful inside a unit like this, and I don't recommend opening one up if you don't know exactly what you're doing. Now with that said, these units make it very easy to replace the batteries in them without having to expose any high voltage parts. And this is intentional so that users can actually replace the batteries in their units. So if you're looking to perform a battery replacement, you should absolutely be able to do that. But if you're doing what I'm doing and opening the whole unit up, you have to be extremely careful. After getting the lid off of the smaller unit, I was greeted with one of the dustiest appliances that I've seen in a long time. Oh my goodness. So that's going straight outside and getting the blower fan treatment, and I didn't record this process because I didn't feel like moving my whole camera setup outside, but trust me when I say the cloud of dust released by this thing was absurd. But after a while, I was back with a much more workable unit on my desk. So I took the two lead acid batteries out of the UPS and measured them with my multimeter. And note that these 12 volt batteries should never really drop below 10.5 to 11-ish volts in this application. So with that in mind, I think that negative 0.125 volts and 2.89 volts as the measurements for the two cells indicates a very needed battery replacement. All right, great. What I think I'll do now is set those battery cells aside so I can find suitable replacements, and I'll make sure to take all of the wiring harness bits off of the old ones so that when the new ones show up, I can easily rebuild the battery pack with new cells. But before I continue with possibly ordering new batteries, because there's always a chance that there's something else wrong with the unit, I want to take a look at the bigger unit, as it has the exact same issue, so let's see if the damage inside is the same. That being just dead batteries and no visible burn marks or anything on the PCB. So I opened up the big unit on my desk, regretted that decision immediately, closed it right back up, and blew probably about a pound of dust into the air outside. Yeah, that one was also really bad. I do wonder if there's any possibility of overheating damage in these units now, because mostly with this bigger one, that mat of dust in the front panel was massively thick, and I wouldn't be surprised if it was hugely restricting airflow. After getting that sorted, I removed the battery pack from the unit and measured its overall voltage before tearing it apart and measuring each cell. Importantly, this pack is supposed to be a 48 volt pack, and the pack in the smaller UPS is supposed to be a 24 volt pack. So we really shouldn't be seeing a voltage below 42 volts from this pack as an absolute minimum. When measuring the pack though, I got a reading of a whopping 2.34 volts. Yep, that's definitely within the range of what this pack should be. Not. Looks like this unit's going to need new batteries too, assuming nothing else is wrong with it. But the thing is, if there is something wrong with it, the new batteries will cost me in the realm of $70 just for this unit, and I don't really want to have to spend that money just to guess that it's going to work with the new batteries. Especially because Amazon doesn't let you return lead acid batteries. So I started seeking out a way to confirm the functionality of these units while also not purchasing new batteries just yet. I figured that since both seemed to be in identical condition, if I could confirm one would work with new batteries, then I would feel alright taking the risk on the second one. So I focused on the smaller unit, as that should be easier to work with its 24 volt pack as opposed to the bigger unit's 48 volt pack. What I eventually came up with was this. Both of these units have connectors on the back to connect external battery expansion packs, which, by the way, I have for both units and I'm going to refurbish later in the video once I'm sure the UPSs themselves work first. And this means that I have a very easy way to inject voltage into the UPS from a power supply or external battery, and this might just work for confirming functionality. My first thought was to put a 24 volt 10 amp supply on this connector and see if it would boot up. But I ended up getting concerned when thinking about the fact that this UPS would probably try to charge my bench power supply, and that may not go over very well. So it's a little risky to throw one of my nice bench power supplies onto this battery input, but I don't have another option because I don't think I have any lead acid batteries laying around. Or at least that's what I initially thought, until realizing that my APC UPS that lives under the filming desk lives there alongside its 24 volt lead acid battery expansion pack. So a 2S 2P lead acid battery pack, meaning that it should be beefy enough to test that this UPS at least powers on, right? Well, we can only hope until we plug it in and either blow everything up, find out that the UPS is cooked, or feel the sweet relief of success. So let's just send it. This meant that I stole the battery pack from my main networking and server UPS and hooked its positive terminal up to the positive terminal for the UPS's battery and did the same for the negative terminal, while having a voltmeter in the middle to monitor things as well. I will also note, I switched away from the idea of using the external battery port because I realized I could just use the internal battery port to test initially to remove one more variable of unsureness. So with the jerry-rigged battery pack connected, which by the way, I think it goes without saying, but don't try this at home, it could very easily go south in many ways, I tried to power on the UPS while monitoring the AC output voltage on one of the sockets, but I couldn't get it to power on. As concerning as this was, I also understood that maybe the UPS didn't want to or just couldn't perform a cold start, especially after sitting for so long. So I plugged the UPS into wall power and tried to turn it on, and to my relief, it actually booted up this time. The output voltage looked great, and after the first several seconds, I saw the battery voltage climb up to 27.5 volts, indicating that the UPS was charging the battery pack. As a final test, I connected a computer to the UPS as a load and then unplugged the UPS from the wall to see if it would run off the battery pack that was just hooked up, and it sure did. So, sweet, this test worked perfectly, and beyond just showing me that this UPS worked, it also actually showed me that it might be time to replace the batteries in my main UPS's expansion pack, as they're about 5 years old, and after doing more tests, were definitely sagging in voltage a fair bit, considering the load that was being put on them. Nice, a double win on that one. But alright, that's enough janky troubleshooting for now. Though, I will say that if you like solving problems like this with your devices, you might be interested in hearing about the sponsor of today's video, PCBWay. PCBWay is a company that offers high-quality custom manufacturing services with a wide range of different capabilities, including things such as PCB manufacturing, 3D printing, and CNC machining. I've used all of these services from PCBWay and have found them to be instrumental in creating several of the projects that I've worked on, as well as some of the modifications and fixes that I've featured on this channel. If you enjoy fixing things and building things, check PCBWay out at the link in the video description, as you may just find a custom manufactured part from them to be the perfect thing for your next job. Thank you again to PCBWay for sponsoring this video. So now let's get to ordering the new batteries for this UPS unit, as well as the other, larger one, which I feel confident enough to order because I can't see any issues with its circuit boards, and it exhibited an identical failure mode to the one that I just proved was only caused by bad batteries. Though, before I place a battery order, I want to strip down both of the battery expansion modules for these units as well, because I'm planning on rebuilding those, and ordering all the batteries at the same time was ideal for me logistically. So after setting the 70-something pound battery expansion for the larger of the two UPSs on my desk, I pulled the lid off to take a look inside it. Also, side note before we see the batteries, look at these massive cables and this Anderson power connector. Jeez, these units are beefy. Anyway, underneath this sheet of foam, we can see 8 very swollen and bulging 12-volt 9-amp-hour high-rate lead-acid batteries. All of these cells were very dead after measuring them, unsurprisingly, and so I tore all of them out of the pack while taking note of the 4S2P wiring scheme, which results in this pack being a 48-volt 18-amp-hour battery pack. After stripping this pack, I switched over to the 24-volt pack for the smaller UPS, which consisted of 8 12-volt 7-amp-hour batteries instead of the 9-amp-hour ones. Plus, these batteries were wired in a 2S4P scheme instead of a 4S2P scheme, so this pack is a 24-volt 28-amp-hour pack. After stripping all of the cells out of both the internal battery packs and the expansions, I placed orders for the new batteries whose main specs in their datasheets matched or exceeded what the original batteries quoted. This is a really important detail to pay attention to, because if you don't watch out for this, you could replace the batteries with ones that won't perform as well as the originals, and this could cause their lifespan to be severely shortened. Plus, it could also cause the UPS's runtime or max output power to be lowered, and worst case, they could completely fail and die, possibly in a semi-spectacular manner, which could also kill the UPS unit. So buy the right batteries. Pay attention to voltage, capacity, dimensions, type. BRLA and SLA are the same thing. Gel batteries are different, so be wary of those. Maximum discharge currents, terminal sizes, and discharge rates per cell are also critical. About a week later, the batteries had all arrived alongside an 80mm Noctua fan. I bought this fan to quiet down the fan in the smaller UPS, as both of these units use the exact same Delta Electronics 80mm server fan, and it's not the quietest thing in the world. I obviously wanted to be careful when switching the fan out for something quieter, because the quieter fans almost always move less air and have less static pressure than the louder server fans. After some testing, I trusted that this Noctua fan would be sufficient for the smaller unit, but I wasn't sure if it would be good enough for the bigger one, and so chose to leave that fan stock. In any case, I spliced the correct fan connector to the Noctua fan and installed it into the smaller UPS, all of which went very smoothly. Plus, it quieted down the unit a lot. And after doing some pretty serious load testing, the air this fan was exhausting hardly got warm under any circumstance, so this mod was perfectly alright for this unit, and honestly might have even been okay for the bigger one. Now, the next step on the agenda was rebuilding the internal battery pack with 2 new batteries, and this was a super easy job. These 2 batteries are just wired in series, and apart from struggling to tuck the stiff wires in tightly, rebuilding this battery pack was no issue. However, a word of caution, I strongly advise not plugging the batteries in with the top cover off, if you even have the top cover off in the first place, which you shouldn't if you're going through the standard procedure. I say this because once the new charged batteries are installed, you have no clue what parts of the UPS will be energized and with what voltage. So you should treat the entire internals of the unit as if they're energized with mains, because they very much could be. With the UPS plugged in and powered on, again, don't do this with the top cover off, everything seemed normal. So I chose to close the unit up and give it a quick test with a computer as a load. Powering the PC on mains, everything was just fine, and the moment I cut mains power, it switched over to the battery seamlessly, and the PC stayed on the whole time. Sweet! Let's slap some labels on the front and move on to rebuilding its battery expansion now. Rebuilding larger packs such as these is really quite straightforward, as long as you're dealing with a decently safe battery type such as lead acid, and they're not absolutely ginormous. This 2S4P pack should be a piece of cake. But while I assemble it, let's talk about some safety things with these bigger packs, and honestly, these notes go for even the smaller 2-battery internal battery packs in most UPSs. It's important to remember that when building multi-battery packs, it's ideal that all of the batteries are right around the same voltage. If they're not, you can end up with charge imbalances that can lead to excess, damaging current flow into and out of some of the battery cells. And while generally the discrepancies will even out over time with lead acid batteries, they can still definitely decrease the overall lifetime of the pack. So start with cells right around the same voltage. And luckily for me, all of my batteries arrived charged within a few tens of millivolts of 12.9 volts, so plenty close enough. Now, the next thing to keep in mind when building with these battery packs is that you can't turn them off. Remember, you're building with charged batteries. Even a battery that's discharged still has a decent voltage potential as well and will dump a lot of power if shorted. So be very attentive and careful with every single connection you make, because if you mess up, it will go south immediately, and depending on the size of the pack and the batteries, it could be really bad. On a similar note, depending on the size of the battery pack, you could definitely end up near voltages that are considered unsafe as they're able to electrocute you. Again, you can't turn these voltages off because they're coming from the batteries, and last time I checked, they don't have an on-off switch on them. This pack is a 24 volt pack, and I'm being careful to never ever connect more than 2 batteries in series, so I should never end up above 24 volts of potential in this pack. However, when we get to the 48 volt pack later, you'll see me wearing some nitrile gloves as extra protection, as 48 volts is the dividing line between what's considered a safe and unsafe voltage, at least in general, and since the pack is 48 volts nominal, that means that with the charged batteries, it'll be closer to 52 to 54 volts. And with that, the 12 volt expansion is built and ready to be tested. So after measuring the output and making sure it's a nice 24-ish volts, again, 24 volts is nominal, so the output can range a bit above and below depending on the charge level, I plugged the pack into the UPS and gave it a whirl. Thankfully, it all worked perfectly, and I think that I can call this unit good to go. I ended up putting roughly $175 worth of batteries into the UPS and its expansion, and since I got the unit for free, I ended up getting a great UPS with a huge runtime capacity for only about $200, accounting for the cost of the fan. I ended up selling this set off for just under $400, making just under $200 of profit, meaning that this was a worthwhile use of my time. All right, now onto the bigger unit. As I've already alluded to, the higher voltage battery packs in this unit require some more caution when assembling, but still aren't too bad. Assembling the internal battery pack was a little tricky with all the plastic pieces it needed, but I eventually got it, taped it up, and threw it back into the unit. Once it was in, I wired it up and gave the unit its first test. And it works! My gamble on whether or not the batteries would fix it paid off. This big unit is really awesome. 1200 watts of pure sine wave output is plenty enough to power even my beast of a desktop PC. And after testing running that whole setup on battery, roughly 800 watts worth of draw, I could be certain that this unit was ready to return to service. But not without its expansion, so let's take care of that really quickly. And yeah, this was the sketchier of the 2 packs to build. It's important to be cautious of the sheer amount of energy stored in these big battery packs, especially as the voltage increases, because while more batteries in parallel can technically deliver more current, higher voltage packs can both shock you and generally drive more current through anything that shorts them, as they won't be as limited by the resistance of the conduction path as a lower voltage pack will. In any case, with the pack assembled and plugged into the main unit, I powered it up and drew a bunch of power from it using my hot air soldering station, and was confident that I had managed to save this UPS too for only about $200 in batteries. I ended up selling this one for about $550, so I made a $250 profit from this one and a $450 profit in total. I'll take it. Well, that's all that I have for you in today's video. I hope that you were able to at least enjoy it and maybe even learn a thing or two. In any case, I hope to see you next time. Goodbye.